Next time you're waiting on a plane during taxi, look out the window. You'll likely see a massive two-digit number painted in stark white on the concrete runway. Every few decades, an airport crew has to come out, grind that massive number completely off the pavement, and paint a brand new one in its place. The runway has not moved an inch. The airport is sitting in the exact same location it always has, yet its permanent identifier has somehow changed. To solve why stationary concrete changes its name, we have to reverse engineer the absolute most basic rule of flying, dealing with the wind. Planes take off and land facing directly into the wind. This aligns with the physics of lift, allowing aircraft to use less runway while making for a shorter, stabler, and safer operation. In aviation's early days, a simple fabric windsock told the pilot which way to point. But as airplanes grew larger and urban airports expanded, planners needed a permanent infrastructure solution to track complex weather patterns. This chart is called a windrose. It is a graph showing the historical wind frequency and strength from various directions at a specific geographic site. Record enough data, and a clear picture emerges. The random gusts fade away, revealing that the wind predominantly blows back and forth along one specific axis in most locations. Civil engineers use that exact axis as their blueprint. They lay down thousands of feet of permanent concrete runway directly parallel to that dominant wind line. Because these static runways are forever locked to the invisible shifting winds, aviation pioneers needed a standardized naming system to communicate direction clearly. Aviation borrowed its directional logic straight from maritime sea ships, adopting the standard 360-degree compass circle. North is 360, east is 90, south is 180, and west is 270. The crucial rule here is perspective. A runway number does not represent the direction the pavement points outward from the airport. It represents the precise compass heading the approaching plane must fly to line up with it. If a pilot approaches from the south to fly north, they point the plane to a heading of exactly 360 degrees. To save syllables over busy radio channels, air traffic control rounds that degree to the nearest 10 and drops the final 0. These identifiers are literal, low-tech maritime compass directions, scaled up and painted onto the concrete. There is a fatal flaw built into this system. Navigational compasses do not point to geographic true north, the mathematical top of the spinning globe that modern GPS uses. A compass is simply a magnet. It exclusively follows the Earth's magnetic field, pulling the needle toward magnetic north instead. To find the origin of that magnetic field, we have to plunge deep inside the planet, past the crust and mantle, to an inner core surrounded by a massive, superheated ring of liquid iron. The Earth's rotation whips this liquid metal into massive convection currents, turning the entire planet into a giant, spinning electromagnet. Because this core is a sloshing liquid and not a solid structure, the electromagnetic field it generates is incredibly volatile and chaotic. The Earth's magnetic North Pole is not a fixed point. It is a moving target, continuously wandering across the top of the globe as the core shifts beneath it. This wandering pole leads us right back to our repainting paradox on the tarmac. As magnetic north moves, the absolute compass headings of stationary runways drift entirely out of alignment. Over a few decades, an approach that was perfectly 360 degrees will drift to 354 degrees, forcing a mathematical round down. The airport must send a crew to physically scrape away the 36 and paint a 35 to reflect the new magnetic reality of Earth. This creates a unique geographic headache. Because Canada's airports are closest to the wandering magnetic pole, the angle changes rapidly, forcing them to repaint their runways far more frequently than equatorial airports. Canada solved this by abandoning global aviation standards. They dropped the traditional magnetic compass entirely, switching their runway numbers to align with the unmoving, mathematical true north using GPS. This creates a schism in the sky. Pilots today navigate using two completely different measurement systems, depending entirely on which airspace they fly into. The next time you look out the window at the pavement, consider what you are actually seeing. That paint is a real-time analog tether to the volatile liquid iron sloshing thousands of miles beneath your seat.